Assalamu alaikum everyone, this is Fattah and your classmate at Advanced Data Structure course with Dr. Azreen, and this is my second demonstration and it will be about splay trees. First of all, I will talk about what are the motivations behind using splay trees. Actually, there are some problems related to AVL trees that motivate us to use splay trees. One is the need for extra storage and complexity for height fields in AVL trees, because we need to store for every node the difference between the height in the left subtree and the height in the right subtree. Second is a problem related to delete code. The solution is using splay trees. Splay trees are blind adjusting version of AVL trees. Their amortized time for all operation is O log n. In the worst case, the time is O n compared to O log n in the AVL tree. The insert and find always rotates the node to the root, and this is an important point. For every insertion or searching, we must splay the node to be the root of the whole tree. What are the splaying cases? As I mentioned just now, splaying means making some certain node n as the root for whole the tree, and this node n is the recently used one. So node being accessed n is either root or child of root, or has both parent p and grandparent g. These are the three cases: root, child of root, and has parent p and grandparent g. For the third case, we have some pattern, the same patterns that we talked about when we present AVL trees. Zig-zag pattern, grandparent, parent, then the node is either left or right, and the second pattern is zigzag pattern, grandparent, parent, and then the node is either left or right left. Okay, the first case, accessing the root. It's very simple, just do nothing as shown, because the node that we want to splay is in the root already. The second case, accessing child of root. This button is called zig because the node that we want to splay is the direct child of the root of the tree. Here we do an AVL single rotation. For example, here we have P parent and the direct child is N. Just do a single rotation, change the rules of N and P, and separate the left child of N to be the right child of P. N becomes the parent, P becomes the child, and Y, which was the right child of N, becomes the left child of P. Okay, for the third case, we access left or right grandchild, and this pattern is called, as we talked earlier, zigzag pattern. AVL double rotation. Here we need to splay the node. For example, here we need to splay N, and we have parent and grandparent, and the pattern, as you see, zigzag pattern. What we need to do is making N as the parent for the whole tree and splitting the tree into two subtrees, P with W and G with X, and the left child of N, which is Y, becomes the right child of G, and the right child of N, which is Z, becomes the left child of P. Okay, what about the zigzag pattern at the left left or right right grandchild? Here we have an example: grandparent, parent, and we need to access the node N and splay it to be the root of the tree. Here we need to rotate top down. What's that mean? Meaning that N becomes N, which is at the bottom of the level of the tree, becomes at the top level of the tree, and G becomes at the bottom level of the tree. To do this operation, N will become the parent of P, and P will become the parent of G. The left child of N becomes the right child of P if it's available, and the left child of P, if there is left child, becomes the right child of G, as we will see here. N becomes the parent of P, and P becomes the parent of G, and Y, which was a left subtree of N, becomes the right subtree of P, and X, which was a left subtree of P, becomes the right subtree of G. That's it. Now we will take an example of splaying. In this tree we need to splay 6. Splaying 6 meaning that making 6 as the root for the whole tree. How we do that? The first pattern that we see is parent grandparent zig-zag pattern. Parent, which is 5, and grandparent, and the pattern is zig-zag. We need to do a top down rotation, as we just explained. How to do that? 6 becomes the parent of 5, and 5 becomes the parent of 6, and that's it. Still splaying. Now we have a parent and a grandparent, so the pattern is still zigzag. What we need to do is making 6 as the parent of 3, and this left subtree of 6 as the right subtree of 3, and making 3 as the parent of 2, and that's it. So 6 as the parent of 3, and 5, 4, which was the left subtree of 6, becomes the right subtree of 3, and 3 is the parent of 2. The last step in splaying 6 is a symbol rotation, because here we have a zig pattern, and 6 becomes the direct child of the root. Just do a symbol rotation by changing the rules of 1 and 6. 6 becomes the parent, and 1 becomes the child, and the 3 becomes splayed to 6. Now it's time for visualization of the previous example. Okay, here as we see, this is our tree and we want to splay 6. We will find the node 6 by pressing this button. Find. When we find it, we will do the splay operation. The first part of this splay operation is to do a top down rotation between these three nodes, 4, 5 and 6. 5 becomes the parent of 4 and 6 becomes the parent of 5, as we will see. Okay, now we will do one more top down rotation between these three nodes, 2, 3 and 6. 3 becomes the parent of 2, 6 becomes the parent of 3, and it takes its left subtree to becomes the right subtree of 3, as we will see. Okay, The last part of this operation is to splay 6 to the root. Now 6 is the direct child of the root, so we will do a zig pattern rotation between 1 and 6. Now the tree is splayed and 6 is at the root as the root position of the tree. Let's now take one more example of splaying. Last time we reached this tree after splaying 6. Now we want to find 4. That means splaying 4 to the root. The first button that we see here is a zigzag pattern. Right, left. So the first operation is a double rotation between 4 and 5, and then 4 and 3. So 4 will be the parent of 3 and 5, as we will see here. 4 is the parent of 3 and parent of 5 after the double rotation. Okay, now we have a pattern of zigzag, but left, right. Also we do a double rotation. 4 becomes the parent of 1 and 6, and 1 takes the left subtree of 4 as its right subtree, and 6 takes the right subtree of 4 as its left subtree. So 4 becomes the parent of 1 and 6, and this part of subtree becomes the right part of 1, and this part of subtree becomes the left part of 6. Let's do now a visualization of this example. Now we want to splay 4, so press find button for 4. After reaching 4, the splay operation begin. The first operation, as we mentioned earlier, take place between these three nodes, 3, 5 and 4. 4 becomes the parent of 3 and 5, as we see. And the second part of this operation takes place between these three nodes, 4, 1 and 6, and it's the button zigzag. So 4 will be the parent of 1 and 6. 1 take this part as its right subtree, and 6 take this part as its left subtree. Now the tree is splayed. In the previous few slides we've talked about splaying operation, and it's time now to talk about insertion and deletion operations. But before we do that, we need to introduce some new terminology. So, division splitting. Split operation take place between a tree and a node X, and it creates two binary search trees, left and right. All elements of T are in either L or R. The union between these two parts L and R make T. All elements in L are less than or equal to X, and all elements in R are greater than or equals to X, and there is no intersection between these two parts. If we have tree T and we split it by using X, a splay operation happens so that T is divided into two parts, left and right, and X becomes the parents of these two parts, so that any node in L is less than or equal to X, and any node in R is greater than X, or any node in L is less than X, or any node in R is greater than or equal to X. The insertion operation of splay tree happens by splitting X. The tree is split into two parts, left and right, and X is the parent of these two parts, and this is the insertion algorithm. Sorry. Insert example. This is our tree, and we want to insert 5 into this tree. The first step is to determine the position of 5 in this tree. It's obvious that 5 is the right child of 4 because it's less than 6 and more than 1 and greater than 4. So we need to do a split for 5 by splaying its parent, which is 4. So the first step is to splay 4. The pattern is zigzag, so 4 becomes the parent of 1 and 6. And the tree is divided into two parts. The first part contains the nodes 4, 1 and 2, and the second part contains the nodes 6, 9 and 7. The last step is to make 5 as the parent of the two parts, and the insertion is completed. Now it's time for visualization of this example. This is our tree, and we want to insert 5 into the tree. So we type 5 and press the button insert. Here the 5 position will be determined. After we determine the 5 position, we see that 4 is its parent, so we do a splaying for 4. As we see here, we do a double rotation, left and right. This is the first rotation, and the second rotation. After this step, the tree is divided into two parts. This is the first part, which is left, and this is the right part. The last step is to join these two parts by making 5 as the parent for these two parts, and the insertion completed. Now I will illustrate the deletion operation in splay trees. We have some tree and we want to delete some element X. First of all, we must find it by splaying this element into the root. This element will divide the tree T into two subparts, left subtree and right subtree. Next we delete X, but we see that the tree is divided into these two parts. So what to do now? We must join them again. Join the left part and the right part, given two trees such that left is less than right, and merge them. To do this operation of joining, we need to splay on the maximum element in the left subtree and then attach this element to the right subtree. To summarize this operation, we can say that we have a tree. The first thing is to find the element to be deleted, which is X, and splay it. So we divide the tree into two parts, left and right. Then delete X. So now the tree is divided into parts, left and right. The next step is to join these two parts by splaying the maximum element in L and then join it with the right part to make a new tree that is equal to the original tree excepting the deleted element X. Now this is our example of deletion. We have this tree and we want to delete the item 4. The first step is to find 4 and splay it. As we see, the pattern is zigzag, so we make 4 as the parent of 1 and 6. The second step is to delete 4. Now the tree is divided into parts. The left part is
the left part contains 1 and 2, and the right part contains 6, 9 and 7. The next step is to find the maximum element in the left subtree and splay it on, which is 2. We splay 2 on and join it with the right subtree. After this join operation, the deletion is completed. Now we will use the applet to visualize the deletion operation. Okay, we type the element to be deleted, which is 4, and delete, and press the delete button. First of all, we determine the position of 4. After that, we splay it 4 by doing double rotation, because the button is zigzag. This is the first rotation and this is the second rotation. After that, we delete 4, so the tree is split in two parts, left and right. Now it's the time for joining. For joining purpose, we splay on the maximum element in this left subtree, which is 2, and then join this element with the right subtree. So now the deletion is completed. Okay, brothers and sisters, we reached the end of this demonstration of splay tree. Thank you so much for your attention, and see you again in the third presentation about red black tree.